Hi everyone. I hope everybody's doing well. And today we will talk about weather. And so we're moving to the next so to say section of the course. So remember we focused on the climate on your up to the first section of the course up to the exam one, and the second one, which would be about weather, and this would entirely cover the what will be included in exam two. So before I start today's lecture, I just want to briefly mention that I've looked at the how you performed in exam one, and most of you have done really well. And but there are questions that many students missed. Some questions, but generally, I would look at your exams, and then what everybody scored, and I'll put it on the Excel sheet, and then put it, of course, and post your grades and the iCollege, right? And then remember, we're going to have 4 exams, and then I'm going to drop one of the exams. So you still, if you haven't done well in the first exam, so you still have like exam 2 and exam 3 to do well, and then of course a final exam. So you still have 3 exams, like you get 3 more chances to do well in the course. And this week, of course, our attendance quiz will be posted. But please reach out to me if you're having problems accessing the materials, or even like if you feel like the study guides or the materials that I've posted on iCollege were not didn't really help you to prepare well for the first exam, and then we can discuss that in private in more detail if you have any issues. All right. So one of the questions I had for in the first exam was like, what does climate determine on Earth? So before I start talking about weather today, and which would be very brief and very general, I just want to remind you that, like, when we're talking about the climate, we're talking about long-term changes, right? Climate is about the trends. Remember, I've had this course, climate is your personality, while weather is like your mood, right? So your mood changes day to day, right? So when we're talking about climate, we're not talking about how sunny a day is. That's weather, right? Climate has no bearing, has no impact, actually, we could say, on what's happening on that, like, very short and limited geographical scope as well. What's happening on a very short time period, right? So what climate determines is actually the type of plants and animals that can survive in a region. Okay, this is how I'll explain. When we're talking about type of plants, we're talking about, for instance, if you look at in Atlanta, type of plants, the type of vegetation we have, it's actually it's determined by climate. And why? Because weather is like short term, right? So when we're talking about the type of plants, so it's like we're already talking about long-term changes where the vegetation types have enough time to adapt to the climate system, right? So whether it is like, for instance, rainy, very sunny, that's weather, right? But like for the plants, like to really survive, and for vegetation type to survive, like what we're seeing in Atlanta, they really need to adapt to the climate, because they really it takes a lot. That means they need to take in account the what was happening over a very long period of time. And so now we're talking about the climate. But again, the climate doesn't really control what's happening on a daily basis. Okay, so let's what about weather? Okay, well, when we're talking about weather, we're actually you've seen this slide before in the introduction, in during our first lecture. So we're talking about now the atmospheric conditions over a short period of time, right? And then we're actually looking at a specific region. Remember, when we're talking about weather, for instance, the weather today here in Atlanta might be a little different from the weather in Athens, right? So, for instance, if I ask you, what's the weather today? Oh, it's a bit chilly, and it's clear blue skies, so anticyclone. And you remember, like, anticyclones are associated with clear blue skies, where cyclones tend to bring thunderstorms, right? So, for instance, in Athens, we can have in Atlanta, for instance, we can have blue skies, and then there might be temperatures across geographically, doesn't change like significantly that much, but like, for instance, in terms of humidity, in terms of precipitation, there are like key differences between locations. Even for instance, within the counties here, there might be differences in weather, right? And meteorology is the study of the science of weather, right? So meteorologists, they care about they care about what's happening on a day-to-day time scale, right? And so, for instance, if we're talking about weather forecasting, I'll have a lecture on weather forecasting and in subsequent lectures. But when we're talking about meteorology, we're talking about the study of this day-to-day changes in atmospheric conditions, right? Whether it is precipitation, whether it is temperature, right? While climatology is the study of the climate. Climate is, we're studying long-term changes, right? Very slow processes that occur on a characteristic, let's say, with time scales of 30 years, right? We need, for instance, decades of data to understand the climatology of a region. And then this is not actually, we're not focusing on a specific region, but more broadly covers large areas, right? And then, of course, when we think of weather, it's actually very, very easy to visualize, and then we can think of thunderstorms, hurricanes, and cyclones, anticyclones, but it's hard actually to visualize the climate, right? Because the climate represents that background, slow-moving change in atmospheric conditions that takes place over a longer period of time, decades, right? For instance, we can say, of course, the globe keeps warming, and we could say, of course, there's more likelihood of this extreme weather events, right? So as the background changes, of course, we can say this thunderstorms are likely to become more frequent in many places, but again, it's actually it's not easy to visualize climate change, but it's not easy to visualize climate, but it's actually quite easy to visualize weather, because we can actually, these are short-term change, for instance, we can actually link this weather extremes to weather, right? It's easy to visualize weather. For instance, like if I ask you what are some of the memorable weather events that have happened in your lifetime, you can think of it was super cold during this winter, like 5 years ago or 10 years ago. But like, it's hard to say the same for climate, right? Because climate, it's a very, very slow change typically, right? The time scale is different, right? And you probably remember this particular image. It's from the Chasing Ice documentary, and well, for climate, it's actually this slow moving process, it's hard to capture, but like a good example to visualize climate and climate change is probably the collapse of an ice sheet, right? It doesn't really collapse on collapse and recover on a daily time scale. It takes it really takes thousands and thousands of years for these ice sheets actually to take their present form, right? But for it to collapse, it's actually a slow process. But what we're experiencing today in the high latitude is that it really actually reflects, it's a more reflection of the rate of change, right? The extent of warming that triggers such collapses as you can see in this image, right? So the first visualization of climate change is actually that documentary manifests this helps us in a very it's actually very captivating, and it helps us visualize what climate change looks like, right? All right, so there are of course key variables, key elements of weather. These are temperature, wind, pressure, humidity, and precipitation, right? And then, so for instance, if I ask you, if you only have if you only had to pick 2 from 5 for weather forecasting, and which variables would you pick, right? So for instance, I would pick temperature and pressure, and then I'll explain why. So if you have temperature and pressure of the air, so because we talked about the wind is driven by what? The pressure gradients, right? Temperature actually impacts the pressure, and pressure actually impacts the wind. So all these five variables are interrelated. For instance, if there's you have a lot of precipitation, then that means there's a lot of moisture in the air, and then that also impacts the humidity, right? As I'll explain later, humidity is the amount of water vapor that we have in the atmosphere, right? So temperature, wind, pressure, humidity, and precipitation are very important elements of weather, but some are more important than others, right? So for instance, temperature and precipitation, the temperature and pressure actually, they control whether a place is going to, you expect a precipitation, or a place is going to be humid, or we're going to have strong winds or strong wind gusts or not, right? But these 5 elements are required inputs for weather forecasting, right? So what's temperature? Well, temperature is a measure of how hot or how cold the atmosphere is, right? And the SI unit, like the internationally recognized unit that we use for when we're writing scientific papers, is degrees Celsius, but of course degree Fahrenheit here, especially in the US, is widely used, and of course you can easily convert the degree Fahrenheit into degree Celsius and vice versa, right? And while wind, when we're talking about wind, well, we're talking about the movement of air masses, but the most important point here is what controls the movement of air masses, right? And so even if we're talking, let's say, for example, surface winds, what drives the winds? So winds are fundamentally driven by the pressure gradient, right? I gave you this example, for instance, when you're opening a refrigerator, right? You just feel the cold, right? So that means there is a movement of cold air from inside the refrigerator to the outside, because there is a gradient which is, for instance, if you're at home, then it's warmer. Of course, the surrounding air is warmer, while the cold air it has its focal point, it's concentrated inside the refrigerator, right? So when you open it, there is a gradient. So there is a movement of air from the high pressure point, which is inside the refrigerator, to the relatively warm air surrounding it. That is the low pressure zone. So wind, when you think about, if you don't really have the gradient, then you don't have wind. Basically, it's as simple as that. So the movement of air is actually also driven by a gradient, right? And then, of course, we've discussed about the Coriolis force, how it is important. Well, the wind is actually the Coriolis force give it a certain direction, right? And I'm not going to go that into detail because we have discussed this in previous lectures before. But I just want to mention that, like, the atmospheric pressure and the air pressure is also very important, right? Because it's the pressure change between different bodies, whether we're talking about the ocean or the land surfaces, that actually drives the wind, right? So it's because of these pressure gradients, then we can have, for instance, if you have a high pressure point located over the ocean, and then you have a relatively warmer low pressure zone over land, what happens is that the winds would start blowing from the ocean to the land, right? Because of the pressure gradient. And then what would happen? And then you also have, because there is a lot of moisture over the ocean, clearly, then you expect a lot of moisture transport as well, right? It's not just the movement of air, but the air also potentially, if it is like coming from the ocean, brings a lot of moisture with it, right? And we'll talk about the density of the density of the air, for instance, when we're talking about the altitude changes, right? So, for instance, as you go up, right, if we're talking about the weight of air resting on Earth's surface, if we define atmospheric pressure as the weight of air resting on Earth, that's the reason when you when you're hiking a mountain, so the air gets thinner and thinner, right? So we're talking about density. So it's also a function of density. So the change in atmospheric pressure is also a function of density. All right. But humidity is the amount of water vapor held in the air. This is very important, right? We're talking about water vapor, an important, it's actually a very efficient greenhouse gas, like the other greenhouse gases like carbon dioxide, methane, but humidity, humidity is actually the amount of water vapor that's contained in the atmosphere is easily removed from the system, right? So the water vapor has actually extremely short residence time in the atmosphere, so it can't really keep a place warm for a very long time because it has a short residence time. But when we're talking about humidity, we're talking about the amount of water vapor held in the air, right? So, for instance, when it is more humid, it feels very much like the tropics here in Atlanta, right? It's very warm. That's because, remember, water vapor is an important greenhouse gas, right? It doesn't really it serves as a very thick blanket in the atmosphere, right? When you have a lot of water, so that means the heat is not escaping, right? It's not able to escape. So there are two ways to measure relative humidity. One is absolute humidity, that's the measure of the exact amount of water content we have in the atmosphere, and then the other one is relative humidity. That's the amount of water vapor that an air can hold compared to the amount it can hold at a specific temperature, right? I'll explain this in this slide, right? So I actually please check the relative humidity today, right? I want you to check the relative humidity change over the course of the day, right? So, for instance, if you check the relative humidity today, it was more closer to 100% in the morning, right? At 6 a.m., right? That's because there is also enough water vapor and then the air parcels were tight, right? So it doesn't require so much water vapor to fill that air parcel, right? So we say it is the relative humidity is 100%. But like as the day progresses, around noon, for instance, there is already the of course the weather it's already warmer, and the air parcels, of course, they are bigger, right? So it would take even if we don't really have any change at all in the amount of water vapor, but like because the air parcels are bigger, right? And this is because of temperature, and like the air expands. Now the air is actually, it requires more water vapor to saturate the air, right? To fill that air parcel, right? Think of it this way. For instance, the circle, well, it's called the air parcels are very small, but as the day progresses, and then for instance in the afternoon, that's like typically where we have the so to say the biggest relatively bigger air parcels. So then even if the water vapor doesn't change like at all throughout the day, the relative humidity changes, because relative humidity, we are actually it's not the exact amount, we're not measuring the exact amount of water vapor, but we're comparing it to something else. Okay, I'll explain this in I'll give you an example, better example, right? So think of it like measuring your height, how tall you are in comparison to something that grows really fast, right? So for instance, how tall you are, it doesn't really change, right? Like for instance, after a certain age, you don't grow, right? It doesn't really change. Let's say you are 6 foot tall, right? And then, but if you're comparing it like your how tall you are compared to something that grows faster, like in the morning and then in the afternoon throughout the day, then your relative height is also changing, right? For instance, if you're comparing it to tree, let's assume this tree grows throughout the day, right? In the during let's say at 6 p.m. at 6 a.m. In the morning, you compare how tall you are with the tree. Well, of course, like you're as tall as the tree, right? And then, but like if the tree keeps growing, then your relative changes in height also changes, right? So that's exactly relative humidity. So it's not the exact measure of the amount of water vapor we have in the atmosphere. But for you, I want you to remember that the relative humidity, when we're talking about humidity, we are talking about the amount of water vapor that's contained in the air, right? So if there is a lot of air in the atmosphere, and then it would feel warm, because water vapor is an important greenhouse gas, right? All right. What about precipitation? Well, there are important processes that we're going to come back to, that we're going to describe about precipitation, right? But precipitation, and simply put, it's the product of rapid condensation process, right? What do I mean by condensation? Simply, condensation is the change in state from gaseous matter changing its phase to a liquid matter, right? So that's the transition of a gaseous body and to a liquid form is what we call condensation. The opposite of condensation is evaporation, where we have a change in phase between liquid and, for instance, we say evaporation, it is the change in phase of a liquid to its gaseous form, like water vapor, right? Water vapor is it's the form in its gaseous state, and while in its liquid form, we just call it water, right? And of course, as the temperature cools, then we have condensation in the atmosphere. We'll come to this point in more detail in the next lecture. But there are different forms of precipitation. Whether, like, for instance, why do we have snow? Why don't we have snow here in Atlanta during winter? Why do we have only? Why is it just rainy here in Atlanta? We'll explain. We'll discuss that in later. But there are different processes that determine, that control why a certain region it's more to have precipitation expressed in terms of rainwater in certain places, in snow, and in other places, right? And but remember, it's fundamentally we're talking about condensation here, right? All right. So precipitation is a result of condensation, right? And then there are different ways of measuring weather, right? And but weather fundamentally begins with the sun, right? So what I mean by it begins with the sun is we're always going to have differences between the poles and the tropics, right? The sun is always overhead in the tropics, right? So it actually there is the amount of insolation, the amount of radiation reaching the poles, and just because of the more because the our planet is spherical, it's going to create these differences. So the poles will always be colder compared to the tropics, right? All right, let's. How do we measure the weather then? Of course, we talked about the those 5 important variables, right? 5 very important elements. Those are precipitation, temperature, humidity, pressure, and wind, right? And then they are all interrelated. And then we have this global networks of weather and global networks of stations, weather stations, right? Measuring these 5 key variables, right? So these 5 key variables control and they actually regulate weather, right? So the weather is, we can say it's about this 5 elements, right? But since the 70s and the 80s, but now we even have like if we're just like talking about weather stations, of course they are spatially limited, right? For instance, if you look at the network of stations we have in the US, it's not exactly uniformly distributed, right? Right, and then for instance, it's not as simple as setting up a station on land. Setting up station over the ocean is not as simple, right? Now we have satellites, right? So the satellites are used to photograph and track large-scale air movements, both over sea and on land, right? And then these images, because all the variables are interrelated, right? By analyzing these images, we can actually accurately quantify those important variables, right? So before I conclude today's lecture, for instance, I just want to show you the Ventusky app here. Of course, there is a lag here because when you see this on your recorded videos, of course, it wouldn't be as fast as like if you just go through to the Ventusky.com website, and then you'll be able to see these changes in real time, right? This is possible because of satellites, right? And then we can actually quantify changes in temperature, precipitation, right? And the movement of different air masses. Like, let's just briefly dive into the US, right? Here, bear with me here, right? Right? So pretty much the coldest. Okay, yeah, this would do. The coldest temperatures we have here in the US, here is Canada, here is the US, is here in Utah, right? So I'll explain this why. And the reason because is this, of course, you'd expect the temperature change would be, well, if we were talking about the sun, they would be similar across latitude, right? You'd expect, for instance, if you move horizontally from Utah all the way to Chicago, then you'd expect maybe our temperature to be the same, right? Because they are on the more or less on the same latitude. But like this is an example how topography and those altitude changes are also very important. They can impact even across latitude. It's possible to have like differences, gradients across latitude in temperature or precipitation, right? So there is this interaction. Precipitation is all about the gradients, right? We have both the north-south gradients, of course, we talked about between the poles and the tropics, but also because we have different topographies, the topography is very complex, then we have differences. That's why the weather is complex. We have differences in whether it is precipitation or temperature over land, right? And over the ocean, it's probably, for instance, if you see over the ocean, well, it's actually, if you look at the tropics, you see over the ocean, it's more or less smoother compared to the land, right? But we have this for weather. We have this very complex and very complex. Complex dynamics taking place because we're not just like those five parameters, 5 elements are also impacted by topographic changes, altitude, whether you have mountains, whether you're closer to the ocean or whether you're far away from the ocean, and of course that triggers changes in temperature, pressure, those most important variables, and then that would drive changes in precipitation, wind patterns, and humidity, right? Okay, let me go back to my last slide. So I want you to think about this in more detail. So if I ask you what are the most important instruments, of course, think about, we have 5 elements, they are interrelated, but if you have 2 or 3 of those, you can actually calculate the others, right? So the most important instruments are, of course, if you say temperature, if we have temperature and pressure, then we can, if we're able to calculate the other ones, then the most important instruments would be thermometers for weather forecasting. Like if you have thermometers and the barometers, the pressures difference and temperature difference, then, well, of course, for accurate forecasting, you need to have all accurately recorded, right? All the 5 elements. But if you have to pick, and some are more important than the others, right? This is it for today. And again, once the lecture recorded video is posted on Wednesday, I will automatically post the attendance quizzes for the week. And again, like I said, you know what grades you have received already. So if you have any issues, please reach out to me and I'll be happy to discuss.